Hi, so in this video we're going to be looking at integration by parts. Now if this is the very first time you've looked at this topic, please don't look at the question at the end, and if you have looked before and you want to get much better at this topic, please do. Okay, so what is integration by parts? Well, integration by parts has a formula like this, and it's a bit like the product rule when you're differentiating, but this time for integration. So you've got one function of x times another function of x. Now we use integration by parts to convert an integral we can't integrate into, hopefully, one that we can. Okay, so here's an example. So we're going to integrate x times e to the x. So the first thing we need to decide is which is going to be u and which is going to be dv by dx, and they can be either way round. For now I'm just going to use this. I've got u equals x and dv by dx equals e to the x. So I've just chosen which one's my u and which one's my dv by dx. I then work out all the bits I need so that I can use my formula. So I need du by dx. So when I differentiate u equals x, I get 1, and dv by dx equals e to the x, and from this, if I integrate up, I get v equals e to the x, because when I differentiate e to the x, I get e to the x, and so when I integrate e to the x, I get e to the x. I then substitute all the bits into my formula. So I look and find my u, my v, then my v, and my du by dx. I put it all in. Be careful, there is a minus here, it mustn't be forgotten. And then I see that what I actually have here, I've got e to the x times 1, so I've just got e to the x, and the integral of e to the x, as we all know, is just e to the x. So this comes out as x e to the x minus e to the x plus c. Okay, so the key thing here really is that you have to decide which is your u and which is your dv by dx. So you want to make your life simpler. So things that get simpler when you differentiate are the things you want for your u. So your first choice is always, if there's any ln function, is to make that u, because that then becomes 1 over f of x, and you lose the ln immediately. And the second thing you choose, if there isn't a ln function, is a power of x to be your u. Because every time you differentiate that, the power goes down, and eventually, if you do it many times, you can get it back to 1. Okay, now if you make the wrong choice, and you won't be the first person to make the wrong choice, your integration doesn't work. You don't get something which is easier for you to solve, and so therefore you need to start again. Don't worry about it, you won't be the first person. Okay, so here's another question. I've got my integral equals the integral of x ln x dx, and so I'm going to decide, and from what I said before, I'm going to choose u equals ln x, dv by dx equals x. Differentiate ln x, I get 1 over x. Integrate x, I get x squared over 2. So I add 1 to the power and divide by the adjusted power. I then slot all my bits in. So my u, my v minus, don't forget the minus, and then the v, and then the du by dx. So you can see I just put everything in, and that's why it's really important to write these out here, because you'll get points even if you make a slip up here for having it all set out. They can see that you found all the bits that you need. Now hopefully you can see that I can simplify this by getting rid of one of those x's. So this just is x over 2, and this is something that I can then integrate. So x will come from x squared over 2 when you integrate, and then the extra 2 times 2 gives you the 4. So this is x squared over 2 ln x minus x squared over 4 plus c. You can always go much slower and pause and think about what I've done at each stage if I'm going a little bit too quickly for you. Okay, so you might be asked to know the integral of ln x, and this is just a little trick, and it's just a trick that you should try and remember because it is asked sometimes. What we do is rewrite this as 1 times ln x, and then we choose, as we said before, make your ln x u, and then the other thing dv by dx, and your other thing now is 1. Then we differentiate, du by dx equals 1 over x, and dv by dx equals 1 will integrate to v equals x. Then I put all my bits in, u, v du by dx. So I just slotted all in, and you can see that rather cleverly this x and this x cancel. So we're just left with the integral of 1. The integral of 1 is just x, so this becomes x ln x minus x plus c. Okay, I hope that's good. Okay, so if this is the first time you've seen all this, please go away and have a cup of tea. If not, stay with me. So this is slightly harder, sorry. We're going to try and integrate e to the x cos x dx. Now for this, there's no ln x and there's no power of x. And actually in that case, you can choose either to be your u and your dv by dx. So I'm going to let my u equal e to the x and my dv by dx equal cos x. Then my du by dx will be e to the x and my v will be sin x. I substitute everything into my formula here, and then I think, oh, that's not very nice. This hasn't got any better. This is actually no nicer than the thing I started with. But there's a trick for this sort of question. You then use integration by parts a second time. So we have this, and we're going to use integration by parts on this bit here. So this time I'm letting my same way round. Let's do the same way round used before. So u equal e to the x, du by dx gives me e to the x. And then this time my dv by dx equals sin x, and so my v will equal minus cos x. So, and that's because when you differentiate a cos, you get that extra minus sign. Then I very, very carefully, watching all my signs, substitute back into here. So I've got the e to the x sin x minus, then put a bracket round, and then you're going to use integration by parts for this thing. So you're going to have your u and your v, and I've just put the minus sign for the minus cos there, minus the integral of your v, which is the minus cos x, and your du by dx, which is e to the x. And here's where the trick comes in. Hopefully you can see that this cos x, e to the x, the integral of that, was your original integral. That's your original I. And so we can now substitute in I for this thing here. So I have I equals e to the x sin x, then I've got a minus and the minus, I've got a plus e to the x cos x, and then I've got a minus, a minus, a minus. So overall I've got a minus, and I've got minus I, because this thing here is the same as I. So now I just add my I onto the other side. So it gives me 2i e to the x sin x plus cos x. It's just a bit of rearranging. Divide by 2, and I have my answer. There should be a plus c there, really. And then I've done it. I've done it. So you just have to go steady. You have to really, really watch your signs. I'm always making a mistake with my signs, so just go very, very carefully. Write them all out. Don't think I can do it all in my head, because then you do go wrong with the signs. Okay, I really hope that's helpful. Bye.